Solving using elimination. So this is the other side. You can always use substitution. Elimination is just a different method. First step of solving using elimination is to write both your equations in standard form. That's that ax plus by is equal to c form. So usually I don't think about using elimination unless they happen to be written like that. Our example here on the right, step 1 is already done. We don't have to do anything for that. And that's usually when my mind goes straight to, well, maybe it'll be easier to do elimination. For this question, additionally why I would choose elimination over substitution is that when you go look for your easy variable to solve for, right, every variable has a coefficient, and if I divide through everything by 4, it's not going to go evenly into 5 or 22. And the same thing if I divide by 5, that's not going to work. And same thing here, 8 doesn't go into 18 or 3. 3 doesn't go into either. So solving for a variable to do substitution here would mean that we're going to end up with a mess of fractions. So this is a place where elimination is going to be incredibly efficient compared to substitution. So we need to really master both to make things easy on ourselves. So once they're in standard form, which this already is, the second step is to multiply our equations, right? We can change them by multiplying by a constant because it's the same equation. That's a rule that we're allowed to multiply both sides, right? And it's the same equation. And we want to do that so that the coefficients on one of our variables are opposites of one another. So it's up to us what we do here. There are two options. Obviously, we can try to make the x's have opposite coefficients or try to make the y's have opposite coefficients. I am going to start by making... it's really a personal preference here, which one you want to use. I'm going to go ahead and use the x's. I'm actually going to show you two ways to finish this off, so I'll do the y's on the other side. So if I want these y's to have opposite coefficients, right now they're a 5 and a negative 3, I would need to multiply both of my equations because I can't multiply negative 3 by something to turn it into 5. That's not going to work. I mean, I could use a fraction, but that's not efficient. So the smarter thing to do here would be to sort of use their least common factor, right? Or not least common factor, the least common multiple, right? Kind of like finding an LCD when you're doing fractions. The least common multiple between 3 and 5 is 15. And we're going to use that. I chose to do the x's instead of the y's because they already have opposite signs. So that's going to benefit me a little bit. So first one I'm going to multiply by 3, make this a positive 15. Bottom I'm going to multiply by 5 and make that a negative 15. We'll have opposite coefficients. So I just need to be careful when I'm multiplying through that I am not making any simple math errors. Maybe using my calculator to double check everything on both of these. Ugh, math. What is that, 90? I would 100% double check that with a calculator if I were you. In fact, I'm going to double check it even as me. Yep, it's 90. So now we have done step 2, right? We have multiplied both and we have accomplished our goal. These two coefficients are opposites. Yes. The reason for this is for when we do step 3. Step 3 says add the two things together, making sure that the equal signs line up, that we're adding the left sides and the right sides. If we add the right sides, 15 minus 15 should be 0 x's. They eliminated. This is the elimination step. It's step 3. So we have managed to eliminate our x's, leaving us with only 52y is equal to 156. And now, finding y, we're at step 4. We need to solve for our variable that stayed, right? So we'll divide out 52 and 52, and we will find out that y is equal to 3. Now, step 5 is when we have a couple of options. One option is that we can go ahead and take this y and plug it into any of the equations we want. Probably the first two before we blew these up and made them gigantic. So if we wanted to, for step 5, we could plug on in. I'm going to use the top equation because it doesn't have any negatives. And you know my propensity to lose negative signs. So we get 5x plus 4 times 3 is equal to 22. And we could solve that out. to find our x is equal to 2. So that is one completely legitimate option. I want to try out something else. A lot of books don't even bother mentioning this, but you are also able to just do elimination again. So if you really like elimination, especially if you get out a fraction in this step and you don't want to plug in a fraction, you can just do elimination a second time. So what that would look like is you basically start all over. I had to remember what my two things were. So we had what? 5x plus 4y is equal to 22. And our negative 3x plus 8y is equal to 18. And this time we would go through the exact same work, but we would try to make our y's have opposite coefficients instead of our x's. So when we're doing this, now we sit there and go, oh, well, 4 and 8, their least common multiple would be 8, right? So I don't need to multiply the bottom equation. So this is why some people would have chosen to get rid of the y's and eliminate the y's in the first step as opposed to the x's. Because all you got to do is multiply by a negative 2. We do need the negative so that this has an opposite sign in the next step, right? So if we rewrite this, we now have a negative 10x minus 8y is equal to negative 44. And now our y's have opposite coefficients. So if we do our third step where we add together, the y's will cancel out. That's why we chose the negative 2, and we're clever with that. And we get negative 13x is equal to negative 26. And when you finish solving for your x, you get that x is equal to 2. Same thing, just a different way to get there. So neither is better than the other. It doesn't matter. It's just whatever you find easier, whether you want to plug back in to one of the equations or you just want to do elimination a second time. If you get really good at elimination, this is a really good option. So our last step here, step 6, we should go ahead and do. We need to check our work. So we have an answer. We said x is 2 and y is 3. We got to plug that into both of our equations and see if it makes sense. So for the first equation, 10 plus 12 does equal 22, so it works perfectly. And then the second equation was a negative 3x plus 8y is equal to 18. So negative 6 plus 24 is equal to 18, which is also true. So we are finally ready to write our ordered pair and finish this thing up by boxing up our answer. So that's elimination in a nutshell. I'm going to give you guys another question as an example for you to try. Let's do 2x plus 3y is equal to 17, and 5x plus 7y is equal to 29. So take a moment, pause the video, try this on your own, and then come back as soon as you finish to check your work. So if you're doing this on your own, you could have chosen to eliminate either. Both x and y here are going to get you in trouble or make you do work because 2 and 5, your least common multiples of 10, and 3 and 7, your least common multiples of 21. So either way, you have to multiply both your equations, and you need to multiply one of those equations by a negative. So kind of sucks. I'm going to choose to eliminate the x's because multiplying by 7 does not seem like something I want to do. It's going to make things a lot bigger. Multiplying by 2 and 5 are easier to me. So I'm going to multiply the top equation by 5. That'll give us a positive 10. And the bottom equation, I can't just do a 2 because that'd be a positive 10. I need a negative 2 so that they're opposites. So then I can rewrite my two equations now that I've blown them up, made them bigger. Again, I have to think a little bit. Is that 85? Again, just use your calculator. There's no reason to try to do that sort of math in your head, especially if it hurts you and then you end up doing all this other work and you're wrong. In fact, I'm going to double check both of those multiplications because I just don't trust myself at the end of a long day. Boom. All right, so those are both good. And now that we have our two equations with nice little opposites, we can finally do our elimination step. Add these together. Those will cancel. We get, a single y is equal to whatever 85 minus 58 is. is equal to 27. Awesome. And then it's up to us what we want to do from here. Do we want to plug this back in, or do we just want to do elimination a second time? I'm going to opt for elimination a second time, mostly because I know that some students, if you did pause this and try it on your own, you might have eliminated the y's instead, and I want you to see what your math should have looked like had you done that. So if I'm going to eliminate the y's, top one's got to get multiplied by a 7, so we get our 21 y's. Bottom one has to get multiplied by not only a 3, but a negative 3. Okay, so we'll rewrite our two equations. Again, I'm going to type into my calculator whatever 17 times 7 is, 119. And do the same thing on the bottom. 15x minus 21y is equal to whatever the heck, 29 times a negative 3, which is negative 87. Since I multiplied by a negative, I did double check that negative, 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 they all switch signs, because I got paranoid that I was talking and doing stuff and forgot to switch one of them. Now set up so they're nice and opposite of one another. So if we add this all together, they will eliminate. We have a negative x is equal to whatever that is, 32. And if we want to get rid of the negative in front of the x, we can either multiply by a negative, switch the signs, divide by a negative 1, however you want to think of it. We get x is equal to 32. So we now have two very large points to try out here. So, a negative 32, almost forgot. See, I would have had a problem. That was why it was a good thing I was about to check. And the only thing left is your check. So you check your work. 2 times my x, which is a negative 32. That negative is there. Plus 3 times our y is equal to 17. Is the first one to check, and the other one is 5 times the x plus 7 times our y is equal to 29. And I would literally just type those both in my calculator, say, woohoo, they worked, and then put this thing as an ordered pair. So that's solving using elimination. I'm going to do one last video to get us through Module 9, and that will be the sort of special cases, how to deal with when there are fractions or decimals, and then what happens when our lines are parallel or the same line. What do those look like? So keep watching for those.